In this lecture, I'm going to discuss about some advantages of the digital systems, and we'll introduce the number systems. So what are the types of number systems? How to represent number, right? How to convert one number system to another number system, etc. We'll see. Now, if I go for this digital system, so what are the wherever we see now, everywhere the digital systems are there, right? So everything is processing in digitals only. Now, so there are some advantages. So that is ease of programmability. That means so the same hardware we can use for the different applications, right? So that is the main advantage of this digital system, right? Ease of programmability. Now we can build millions of transistors in a single chip. So that is the reduction in cost of hardware, right? So that is also main advantage of this digital systems, right? And the millions of operation in a single in a second. So that is so the digital system operations can be very high speed, right? And it is very highly reliable also, and it's very easy to design. So that is, suppose if you want to design for some operation or some hardware, so it's very easy to design. Then the main important thing is the result can be reproduced easily. That is, even if some noise is added or some whatever the environment changes, so but we can easily reproduce this result. That is, it is only represented in the either 0 or 1, right? So digital systems are based in only the binary number system, right? So even some noise is added, so we can easily reproduce these zeros and ones in the receiver side. So this is about the some advantages of this digital system. So applications wise, so everywhere the digital systems are there. That is, it may be communication, it may be digital computers, it may be scientific enterprises. So everywhere, so medical, weather monitoring, space guidance, right? Even traffic light controls also, traffic controls. So we use the digital systems only, right? Now, a digital system can be interconnection of digital modules, right? So if we want a digital system, a large digital system, so in digital systems we'll have different digital modules, right? Now we need to know what are the each digital module or what are the each digital logic function will do, right? So we should have some basic knowledge about those digital functions. So for that reason, so we should learn the basics of this digital systems. What are the basic characteristics? So when we design a digital systems, right? Now, how to represent any analog information in a digital domain, right? Or in a discrete information. So we have to convert this analog to discrete information, and we have to represent this discrete information into the digits, right? So it is a binary digits. Only any information, it will be converted into only zeros and ones only, right? So when we convert it into zeros and ones, so what are the logics we need to use, right? So what are the number systems available? So how to represent any number in a different formats, right? So what is the use of those number systems, etc. we need to see, right? So first we will start with the number system, then we slowly will build digital modules, right? Digital logic functions, etc. Right? The first one we will see a number system. Now, what is the definition of this number system? Is a number system with the radix R or base B, right? So we can use either radix or base B. Will have R different numbers starting from 0 to R minus 1 or B minus 1, right? So whenever there is a number system with radix R, so it will have the R different numbers, but the starting from 0 to R minus 1 or B minus 1. So right, that is about the number system. Now, what are the different types of number systems available? Now, there will have any different number systems, but the general we use are binary, octal, decimal, hexadecimal. So in binary number system, the radix is 2. Binary means only it will have 2 digits, that is 0 and 1. So 2 means, so radix is 2. Ternary means radix is equal to 3. So on the what are the digits we need to use? 0, 1 and 2. So only these 3 digits only we need to use. Similarly, quaternary means the radix is 4. So and the digits are 0, 1, 2, 3. Next one is octal number system. So that is octal means radix is 8 and the order the digits 0 to 7. And the decimal number, we know in general we are using the decimal number. So that is at r is equal to 10. So what are the numbers or digits we are having is 0 to 9, right? The last one is hexadecimal number system. The radix is r is equal to 16. See, the decimal number system we are having, from the past. Now what we are doing, they are converting this different systems is, so we are taking some numbers from this decimal number system. See, so 0 to 9 are there. So from 0 to 9, if I pick only 0 and 1, so it will become binary number system. If you pick up only 0 1 2, so it will become ternary. If you become only 4, so it will become on the base number 5 system, etc. If you pick up the 7, so it will become octal. Now if you pick up the 9 plus some extra number or characteristics or alphabets, so that will become hexadecimal number. This system will have the 0 to 15 numbers. Again we need to use 10 11. The a represent 10 11 12 13 14 15. So 0 to r minus 1, right? So because 1 and 0 is already there, so we need to represent in the other characters. So that's why you are using the alphabet, that is a b c d e f for 10 11 12 13 14 15, right? So this is about the some different number system, and we'll have different based on the r, so we'll have so many different number systems also. It may be 5, it may be 6, it may be 7. So 7 means 0 to 6 digits will be there. So anyway, that we'll see when we do some examples, right? Now how to represent any number in any base number system, that we have to see. So representation of a number. So suppose we are having the number n with base b, right? So in this number we will have some the coefficients in this depending on the position. So that's why suppose in base numbers we will have 0 to r minus 1 positions, right? So that is each position value is multiplied with that corresponding base, right? Suppose this is the nth position, so nth position value will be there, and we need to multiply with that base power n. Similarly, p power n minus 1 into p power n minus 1 and so on, p to b square plus p1 b power 1 plus p0 b power 0, plus if we are having decimals, so we'll have to go with the minus, that is p minus 1 p power minus 1 plus p minus 2 p power minus 2, etc. Or we can represent in another way also, that is the positions value will become the, some example is coefficients. So this same n with radix r, so a n into r power n. So this is the position coefficient multiplied with that base or radix power that position value, plus a n minus 1 r power n minus 1 and so on, right? A naught r power 0 for a negative numbers, a minus 1 r power minus 1, etc. When you represent any number like this, so it will come to decimal number system. It will become decimal number, right? So we'll see the example. Suppose 123 is there, base 10. So this is a decimal number. So what is this meaning is, so it will have unit position, that is 10 power 0, then 10 positions, then 100th positions. So how to represent this one is, say this is p0, this is p1, this is p2. Always start from the left, give the 0 to 2, right? So 0 to r minus 1, so 0 1 2. Now what is the number we have to represent? Something like this, 1 into, that is p power 2 into base is 10 power 2, so 100 position, that is 1 into 10 square plus 2 into 10 to the power 1 plus 3 into 10 to the power 0. Now see, if we add this coefficient and multiplication, so this will become 100 plus 20 plus 3. So 100 plus 20 plus 3. So what is this value? 123. Again it is a base number 10 only, right? So that's why any number system, if you represent like this, so it will become a decimal number system, right? Now when we take this is a decimal number system. Suppose if I take some quaternary, some 4, so how to represent in that one? So 1 2 3 can be in the quaternary number system also. So this is the base or radix, right, which will define the what is the number system, right? So in 4 we are having the 1 2 3 values, so we can represent this 1 to 123 in decimal number can be represented in the radix 4 or quaternary, that is 1 2 3, right? So how to represent leaks? So this can be represent, so again this is p power 0 p power 1 p square. So 1 into 4 power square, I mean 4 square, plus 2 into 4 power 1 plus 3 into 4 power 0. So it will become 4 square means 16 plus 2 into 4 8 plus 3 into 4 power 0 means 1. So it will become 3. So 16 plus 8 24 plus 3 27. So this is 27 in decimal number system. Now see 1 2 3 in base 4 will be equal to the 27 in base 10, right? So that is some difference between this. So any number system can be represented by like this. So once we represent like this will become the decimal number system. Remember this point, right? Now we will say how to represent binary number or etc, right? Suppose binary number means only it will have either 1 and zeros, 1 0 1 1.1 0, something like this. So always we need to represent the base, right? Because 1 and 0 in any base number system, 1 and 0 will be there. Suppose if it is a 2, it will have only 1 and 0. Suppose something written like this, so this is not a valid number. Why? So in a base number 2 or in a binary numbers, it will not having any 2. So that's why we need to represent the base, right? Now how to represent? So we need to give the position. So this is p0, p1, p2, p3. So 1 into 2 cube, because this is the base is 2, plus 0 into 2 square, plus 1 into 2 power 1, plus 1 into 2 power 0, plus decimal number is there, so decimal points. So 1 into 2 power minus 1, plus 0 into 2 power minus 2. So 2 cube means 8, 0 into anything means 0 means, so plus 2 plus 1 plus 1 into 1 by 2, so 0.5. How much? This is 11.5. So what is it will become? It's a base 10, right? So once we represent like this, so it will become the decimal number value. Now we'll see the, suppose any hexadecimal number is given. So here the positions we need to give b0, p0, p1, p2, right? So once we have given like this, so how to represent this one? So position value into the base power, that position number, so 16 square, plus b means, so what is the number actually? 11. So it will become 11 into 16 power 1 plus 2 into 16 power 0. So what is this? 16 square is 256 plus 11 into 16. 11 into 16 you will get 176 plus 2 into 16 power 0 means 2 into 1. So what is this value? 256 plus total is 434. So in which number system? So it will become decimal, right? The last example we'll see for the octal. And see the base 16 can be also, sometimes they will return h for hexadecimal. Suppose 1 2 3 base 8, right? So in the base 8, so we'll have the 1 2 3 values. So again, so how to represent? 1 into 8 square plus 2 into 8 power 1 plus 3 into 8 power 0. So 64 plus 16 plus 3. So how much? So 83. It is in base 10, right? So this is about to represent any number system into decimal number system, right? Now we will see the conversion of from one number system to another number system, right? Now we'll see the number base conversions, right? So we have seen if we expand any number into their base and with corresponding positions, we will get the decimal number system. Now how to convert decimal number? So the first one is decimal number system to all other number systems. All other number system. Why I am taking this one is, it is the only one method to find different number systems from this decimal number system, that is the division method, right? So what is this rendition method is? So we have to continuously divide the given number until unless we'll get the last number is in that number systems or not, something like this. I will take example, then it will be very clear. Say what we need to do is, suppose some 42 is there in base 10. Now we have to convert into base 2, also base 3, also base 4, also base 8, also base 16, right? So how to represent in all other number systems? So a single method is dividing method. So first we will divide with 2. So for 2 2's and 2 1's, what is the remainder? So remainder is 0. Then 2 10's 20, what is the remainder? 1, right? Now 2 5's, what is the remainder? 10. 2 5's 10, so remainder is 0, right? Now each quotient again we need to divide, so continuation division method. Then 2 2's, that is 4, what is the remainder? 1. Then 2 1's, so what is the remainder? 2 1's means 2, what is the remainder? 0, right? Now this 1 is in the base number 2, that is in binary number, so we are having 1. Then we can stop up to here. Then starting from the last position, that is bottom to top, if you take like this, right, the values, then it will the binary number system. So if I take like this, so what is the value we'll get? 1 0 1 0 1 0 base 2. That's it, right? So only the one procedure is division method, unless until we get the last number as in this, so we cannot go further or simply like that, right? Or it should be the 1 should be in the base number. Say 2 is not in the base number 2, that's why we need to do division is again, right? Similarly 42 base 10 will be represented with 3, means it will be converted into division by 3. So 3 1's 3 4's, so what is the remainder? 0. Then 3 4's 12, so what is the remainder? 2, right? So 2 is there in this ternary number system, yes. Then 4 is not there, so again 4, so 3 1's 3, what is the remainder? 1. Now how to take the number? So from the top, bottom to top. So that is in quaternary, ternary numbers, what is this? 1 2, sorry, 1 1 1 2 0, this is base 3. Now if we compare from base 2 to base 3, so in base 2 we'll get 6 numbers, in base 3 we got only 4 numbers, right? We'll see how to represent the decimal number into quaternary, that is we need to divide with 4. Now when we want to divide with 4, so 4 10's are 40, so what is the remainder? 2, right? And 2 is existing in the quaternary. Then with division of 4, so 4 2's are 8, what is the remainder? Again 2. Now from the bottom to top, so what is the equivalent? 42 base 10 is equal to 222 in base 4. Now similarly same 42 in octal, 8 5's are 40, what is the remainder? 2. Now 2 is there and 5 is also there in the what you call octal number system. So 42 base 10 will become 52 in base 8, right? Or 5 2. So then last one is 42 base 16, right? So 16 2's are 32, what is the remainder? 10. So 10 is there available in the base number 16 or hexadecimal number system, but we'll have to represent with alphabet, which is A. So 42 base 10 will represent 2A in hexadecimal number system, right? So this is some conversions from decimal to the other number systems. Suppose one more example I'll take. Suppose something like this, 157 point decimal number is there, then how to perform? Suppose 63 base 10. I will do for 1, you do the remaining. So it's very simple. So whenever we are having the decimal point, so the 157, which is integer point, that will become with the same division method. Then the decimal point will be in terms of multiplications we have to do. Suppose I want to convert into base 2, so division with the base 2. So what we do is I will go with 8. Okay, so 8 means, so 8 ones, so 8, the remaining is 5, so 57. So 8 sevens, so 56 will get, so 156. So what is the remainder? 1. Then 8 twos, right? So 16, so remainder is 1. So you know why I have taken the 8, so we'll get only 2 numbers, that is enough. So what is the, it will become 2 1 1 point. Now whenever the decimal points, what we need to do is, so what is the opposite of division? Multiplication. So multiply with the base 8, right? And so when we multiply it with the base 8, so what is this? So 4 50. So what you got? 5.04, right? So in this 5.04, take the integer value, that is 5, and make it this decimal point is again 0.04 and multiply with 8, right? So what is this become? 0.32. Now what is the integer value here? So again it is 0 only. So there is, so again 0.32 into 8. So how much? 8 2s are 16. 2.56, right? So again we have to take about this integer 2. Then what is this no decimal point? Again 0.6 and so on. So it will be a never ending process, but we can go up to depending on the answer, right? So 211 point. Now when we take the decimal point, so we have to go with the top to bottom approach. Here up reverse, that is bottom to top. Now but when we take from the decimals, we got the from top to bottom, that is 5 0 2, right? So this is the only methods we'll have. One is decimal point, if integer is there, then how to do it, the division procedure only. Now I'll give some examples, so try on your own, right? Suppose 1542.10, this is base 10, so convert it into base 5 and base 7, right? And base 16, right? So try to do this, then it will be very clear, so you can do any example or any question from the gate exam also, right? Now we'll see how to convert binary number system to octal or hexadecimal number system. Now in binary number system, so B, that base is 2 and the digits are 0 and 1. And in octal number system, octal O, so what is the base is 8 and the numbers are 0 to 7. And in hexadecimal number, base is 16 and this is 0 to 15, right? Now, so to see how to represent this 8 in powers of 2, right? So I can represent this octal number in powers of cube, 2 power cube. That means the binary number, we need 3 binary numbers to represent one octal number. That is the meaning. So I can represent this 8 in powers of 2 is 2 cube. Similarly, I can represent this is 2 power 4. That means this 3 means 3 binary numbers, at least 3 binary numbers or maximum 3 binary numbers are required to represent one octal number. Similarly, the 4 represents, so 4 binary numbers or binary digits or numbers are required to represent one hexadecimal number, right? Hexadecimal number. Now how to, we'll see. Suppose 101, some binary number is there, right? Now, so when you want to convert this binary number to octal number system, so what we need to do is the standard procedure is first we will convert into decimal number system, then we can convert. Now we will see one example, then it will be very clear. Now this is the binary number system, so we need to convert into octal number or hexadecimal number system. So whenever this is when we want to convert, so what is the procedure is, so first convert into decimal number system, then convert into octal number. Now we said that whenever there are three, so we can represent one octal number using three binary numbers. So it is having three binary digits, so it should represent one octal number. So will it be represented or not, we'll see. So when we convert into decimal number, so what is this, will become 1 into 2 square, because 0 1 2 plus 0 into 2 power 1 plus 1 into 2 power 0, that means 1 only, this is 2 only, so 0 into anything 0, so 4 plus 1, so this is 5. So even in decimal number system also it will become one number only. So one decimal number can be represented by three binary digits. So when I convert this 5 into octal number, so 5 is there in octal number system, so it is also 5 in octal. See, three binary digits can be represented by one octal number. I will give the decimal and binary number and octal number equivalent. So octal means 0 to 7. So we can go, the decimal is 0, 8, and 9 also. But one octal number can be represented by three binary numbers. So 0 means it should be 000. 1 means 001. Reason is 1 in decimal and binary both are same, right? So when I convert this 001 into decimal, so how it will become? 0 into 2 power square, 0 into 2 power 1 plus 1 into 2 power 0, so 1 only. So either octal or decimal both are same. Similarly, the goes like this. So 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So 1 1 means 2 square, 2 power 1, 2 power 0. So 4 plus 2 plus 1, so 7, right? So this is the whenever there is, if you see the 7 in octal number, so we can easily represent by three binary numbers. So something like this, right? Now same in the hexadecimal number, suppose 0 1 2 3 4 5 6 7, hexadecimal. So what is the binary number equivalent will be? We'll have 4 digits, that is 4 zeros, and 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 0 0, 0 1 0 1, 0 1 1 0, 0 1 1, right? And it will go like this. 8 means I will get 1 0 0, 9 1 0 0 1, 10 or A, right? So 1 0 1 0, 11 1 0 1 1, 12 1 1 0 0, 13 1 1 0 1, 14 1 1 0, the last one 15. So what is we'll get is all ones. Now even if you convert, this is a binary, right? So convert into either hexadecimal or a decimal. So how it will become in suppose decimal, if I convert, so 2 cube, 2 square, 2 power 1, 2 power 0. So 8 plus 4 plus 2 plus 1. So it's nothing but 15, right? So this is a 15 in decimal. So how to convert it into hexadecimal? So 15 is existing in hexadecimal. So 15 represented by F in a hexadecimal. So like this, right? So we have to remember this 0 to 15 at least, right? Or 0 to 7 for this octal. Now we'll see one more example. Suppose it's very easy to convert. Suppose 110 0 1.011 is just in binary. How to represent in octal and hexadecimal, we will see. Now how to convert is, so no need of conversion to the decimal first, then again convert it into either octal or hexadecimal. What we need to do, make groups, three groups. When I want to convert into octal, make three groups. So anyway, after the fractions, start from left to right, from left to right, and before this our integer part, go for the right to left. So make a three groups, one group, then there are only two, so make one more 0. So three groups we need to make. So 0 1 means what is the equivalent? It is 3. 0 0 1 means it is 1. 0 0 0 1 1 means it is 3. So directly it is 31.3, 31.3 in octal. That's it, right? So we have to make groups of bits. So if it is an octal, make group of 3 bits. Now same 110010.011. Suppose if I want to convert into hexadecimal, so how many bits we need to make group? 4. Now 011, so no one, only 3, so we have to make add here, not here, right? So if I add here, so this is making a group of 4 bits. So 0110 means it is a group of 6. If we add here, it will become 3. So we need to add to the right when it is a fraction. Now here we need to make a group of 4. So 1001. So there is no 4 bits. So add zeros left side because it will doesn't change the value. So 00. So this is a group of 4 bits. So 0001 means 1. 1001 means 9. So see the table, then it will be clear. 196. So 9 is there in hexadecimal? Yes. So 196 is the equivalent. So just to make a group of 4. That's it. Right? So that is about this one. Right? Opposite also can be. So 6 can be represented in binary by 4 bits. 9 can be represented by 4 bits. 1 can be represented by 4 bits. So the opposite also same. Right? 3. How many bits? 3 bits. 1, 3 bits, 3 bits, etc. Right? So this is about some conversions. So you can have different conversions also, right? So from 2 to, suppose base 2 to base 5. Try to do this also. Suppose 101.01. So what is the equivalent number? You try, right? Similarly into 6, right? Etc. You try to do on your own. So you'll get any, if you are getting any doubt, so please post a comment, right? So this is about some conversions and the binary number systems, types of number systems, right?